The date was March 6, 1990. On that day, the Occupational Safety and Health Administration, OSHA, put a new regulation into effect. They wanted to prevent accidents involving hazardous materials from injuring even one more worker. The regulation applied to hazardous waste sites, treatment, storage, and disposal facilities, and emergency response operations. The range of topics covered by the regulation was impressive, from accidental release measures to monitoring equipment, exposure controls to respiratory protection, decontamination procedures to medical surveillance. It was the most comprehensive standard of its kind ever written. OSHA named the regulation Hazardous Waste Operations and Emergency Response. Most of us simply call it HAZWOPER. An important part of the HAZWOPER regulation deals with how to handle hazmat spills and releases. Because accidents will happen. And they could happen to you. When you are dealing with hazardous materials, even a tiny release can become a major problem. It might look like nothing more than a common puddle, or if it's a gas, you might not see it at all. But it can be very dangerous. Large or small, a hazardous materials release is a situation that must be dealt with quickly and efficiently. No matter where you work, there is always the possibility that a release of hazardous materials will occur. Without a plan of action to deal with these incidents, it could already be too late to be able to respond effectively. By thinking ahead, you can save precious time and be ready for any possibility. Planning for emergencies takes everyone's cooperation. You can begin by participating in your company's hazard communication program. It provides you with the information that you need to understand, the hazards of the chemicals you work with, chemical labeling, and safety data sheet. You will also find that the spill guidelines for your facility can be helpful. These are instructions for cleaning up various types of chemical spills in your workplace. In addition, you should ask your supervisor where you can get a copy of the facility's emergency response plan. This plan spells out how to report and handle emergencies at your location and includes information on the roles of personnel participating in a response, lines of authority, methods of communication, emergency recognition and prevention, site security and evacuation, decontamination procedures, first aid, and emergency medical treatment. The Emergency Response Plan also discusses the 5 levels of training that HAZWOPER requires for your facility. First responder awareness level training must be given to all workers who are likely to witness a spill, leak, or other accidental release of a hazardous material. Since spills are the most common form of releases, we will use them in many of our examples in this program. Awareness level first responders must go through 4 hours of training to learn the reporting procedures that should be used to initiate an emergency response. The first group of workers who actually respond to spills are trained at the first responder operations level. This is for workers whose job is to keep a spill from spreading and to prevent unauthorized people from entering the spill area. Workers involved in operations-level activities must undergo a minimum of 8 hours of emergency response training. After a spill is contained, hazardous materials technicians will locate the point of release and plug, patch, or stop the leak in some other way. These workers must undergo a minimum of 24 hours of training. In many spill situations, hazmat specialists may also be called upon to act as site liaisons with federal, state, local, or other government authorities. A specialist gets the same 24 hours of training as a hazmat technician, but receives more detailed information about the chemicals that are normally on site at your facility. The individual with the most authority in an emergency response situation is the incident commander. This person goes through 24 hours or more of specialized training, which focuses on how to control the incident scene and coordinate the entire emergency response operation. Now, let's look more closely at exactly how a release should be handled and the personal protective equipment that should be used in various situations. Whenever a hazardous spill occurs, an operations-level first responder will immediately evacuate the area and secure the spill. The responder will place barriers or absorbents around the spill in order to prevent contamination from spreading. In addition, they will put up signs or caution tape to let other workers know that there was a spill and to stay away. As soon as the area is secure, the spill site will be characterized. This process includes identifying the chemicals involved in the release and determining the hazards they present. If you are authorized to characterize a release site, you need to make sure that you put on the proper personal protective equipment before you enter the spill area. There are many forms of personal protective equipment available. Combinations of PPE that are used when dealing with chemical releases are grouped into 4 levels: A, B, C, and D. These groups are defined according to how much protection they provide. Level D personal protective equipment provides the least amount of protection. It shields you from nuisance contamination, such as materials that might stain your clothes. It is simply a work uniform and must never be used on any site where respiratory or skin hazards exist. Typically, Level D PPE includes coveralls, cloth or rubber work gloves, boots with steel toes and shanks, safety glasses or chemical splash goggles, and a hard hat. Unlike Level D, Level C PPE provides respiratory protection through the use of air purifying respirators, APRs, which filter contaminants out of the air before they can be breathed in. APRs use the principle of negative pressure. This means that when you inhale, the air pressure inside your facepiece is less than that of the outside air. The power of your own breathing is what keeps air moving through an APR. Level C personal protective equipment is also used in situations where skin hazards are present. Level C PPE, such as a chemical splash suit with a hood, safety glasses or goggles, and gloves, will protect you in these situations. In contrast to Level C, Level B PPE is designed to be used in environments where the air is so contaminated that the hazards cannot be simply filtered out. Here you will need to wear an air-supplying respirator to protect you from the contaminated air. There are 2 major types of air-supplying respirators: the self-contained breathing apparatus, SCBA, and the supplied air respirator, SAR. An SCBA allows you to breathe air from a portable tank. An SAR, on the other hand, supplies air through a hose from a source located some distance away. Both SCBAs and SARs maintain positive pressure. This means that they are forcing a constant supply of fresh air into your facepiece, whether you are breathing in or out. This flow of air from an outside source provides additional protection by preventing contaminants from entering the facepiece. Level B PPE also includes a 1 or 2-piece chemical splash suit with a hood, a chemical-resistant inner suit, gloves, and chemical-resistant boots with steel toes and shanks. Level A PPE is used in places where the most severe skin, respiratory, and eye hazards are encountered. As with Level B, Level A PPE also includes an SCBA or SAR. But unlike Level B, the protective outfit that is worn with the air-supplying respirator is a totally encapsulating suit. This suit completely covers both you and your air-supplying respirator. These suits provide the maximum possible protection against all kinds of chemical exposure by keeping you isolated from the outside air. To provide complete protection, a totally encapsulating suit must be used with a chemical-resistant inner suit made of a material like Tyvek, chemical-resistant outer and inner gloves, and chemical-resistant boots with steel toes and shanks complete the Level A package. No matter what level of PPE you are wearing, make sure that your gloves and other equipment are compatible with any hazardous materials that you are working around. If they aren't, they could fall apart or even melt and leave you completely unprotected. Once you are dressed in the PPE that is appropriate for the incident, you will need to start the site characterization by monitoring the site. Monitoring detects potentially dangerous contaminants in the spill area. This is usually done with direct reading instruments, such as combustible gas monitors and detector tubes. If radiation is suspected, a field survey meter will also need to be used. In addition to monitoring for dangerous contaminants, you should watch out for general hazards, such as open pits or unstable piles of material, and report these types of hazards to your supervisor. After the site has been characterized, the spill itself will need to be contained. The best technique for this is diking, enclosing the spill to keep it from spreading. Be sure to use diking materials that have been specifically designed for the type of material that has been released, such as urethane barriers or absorbent socks. Sandbags should never be used to block any type of spill. They are not made to absorb hazardous substances. Spilled chemicals can leak through a sandbag, allowing contamination to spread. In some cases, the sand itself could actually react with the spilled liquids. Diking should be arranged to keep the spill from running into storm drains and sewers, which could contaminate the environment. If you spot chemicals leaking into a drain, contact your supervisor immediately. When a spill takes place indoors, vents and air ducts leading from the contaminated area to other parts of the building need to be closed off to prevent harmful vapors from spreading to other parts of the facility. Windows and doors to the outside should also be opened in any area where an indoor spill has occurred, so that vapors can escape and safely dissipate in the outside air. If contamination from a release becomes too dangerous, the area around it may need to be evacuated. For an outside spill, windsocks should be used to monitor the speed and direction of airflow through the site. This will aid in determining how the evacuation should be conducted. Once they are evacuated, workers should be kept at a safe distance from the contaminated area. The area should also be sealed off with caution tape to remind everyone to stay away from the spill. Once the spill area has been evacuated and aired out, the cleanup process can begin. Hazmat technicians use many different ways to clean up spills. One of the most common is absorption, using various techniques to soak up the spilled material. To start, an absorbent compound, such as vermiculite, is usually shoveled onto the spill. Disposable towels or spill blankets can also be placed over the vermiculite to help soak up the liquid. Some spills can be neutralized. For instance, putting soda ash on certain chemicals will break them down into harmless substances. Be careful, though. This approach to cleanup can generate a great deal of heat, so it can only be performed on non-flammable materials. Another cleanup method is to transfer the spilled material away from the incident location. For instance, using a pump, you can move liquids from the ground into a barrel. Then the barrel can be properly disposed of. Keep in mind that if the spilled chemical is a flammable liquid or powder, you should only use non-sparking tools, such as plastic shovels, to transfer the material to the disposal container. When cleaning up a spill, it is also important to be careful around electrical equipment. Most liquids conduct electricity, so you need to make sure that nearby machinery is de-energized, as well as locked and tagged out. Be careful, though. Turning a machine off can sometimes produce a spark, which could ignite flammable chemicals. The best thing to do is to turn off the power at the main breaker. If you have questions, ask your supervisor before proceeding. Once the cleanup is complete, all waste products will need to be disposed of. If this can't be done immediately, you are permitted to store the waste at your facility in approved containers. It is important to remember, however, that the storage time in most states is limited to 90 days. After the spill has been cleaned up, everyone involved in the cleanup will have to undergo decontamination, or decon. Decontamination usually takes place in what is called a contamination reduction corridor, often referred to as a CRC. The CRC restricts decon activities to a limited area and helps to keep workers who are still contaminated from leaving the cleanup site. The decontamination solutions that are used in the CRC are usually nothing more than water mixed with detergent. However, if you are contaminated by a substance that will react with water, a specialized decontamination mixture must be used. Remember, once decon procedures have been completed, the solutions used in the contamination reduction corridor need to be properly disposed of. These solutions are often contaminated and must be handled according to specific OSHA guidelines. See your supervisor if you have any questions about how to deal with used decontamination solutions. Working with hazardous spills and releases can be dangerous. Poor preparation can result in catastrophe. But there are a number of things that you can do to help keep yourself and your coworkers safe. Participate in your company's hazard communication program and familiarize yourself with your facility's emergency response plan. Become familiar with your company's spill cleanup process. Know who to notify when a spill occurs and call them if necessary. If you are involved in cleaning up a spill yourself, determine what personal protective equipment should be used and wear it. Once the cleanup is over, make sure that both you and your equipment have been properly decontaminated. Releases of hazardous chemicals do occur. By knowing what you are working with and how you can protect yourself, you can help to clean up these leaks and spills safely.